you are the author of A Brief History of Earth, 4 billion years in 8 chapters. So you're clearly an expert at summarizing massive timescales into really short, concise answers. So I'm going to ask you to flex that skill one more time. This is an unfair question, but can you provide a brief history of Earth? How did Earth originate? How did we get from that to present day? What were the major epochs of the eons in the middle? What were the key features of each eon? How did we go from one eon to the next?
Okay, the first thing to know is that the Earth did not always look the way it does now. It's not even clear that the Earth that we see around us is representative of the Earth through Earth history. It is an end member in many ways. So, and we'll walk us through some of those changes. But to get to your first question, that the Earth originated along with the rest of the solar system about 4.5 billion years ago, when dust and ice started to collide and build into ever bigger structures. And we ended up with, a small number of planets, but also we ended up with a lot of debris from these early moments in the solar system's creation. We call them asteroids when we see them in space, and meteorites when we find that they've bumped into the Earth. And if you ask, how do we know that the Earth is 4.5 billion years old? Well, the answer is that there is uranium in some of the minerals in these early remnants of solar system formation. Uranium is great because it has so-called radioactive isotopes, which is types of uranium that actually decay to lead on timescales that we understand. And they tell us that the solar system came together on this 4.5 billion year old timescale. Now, interestingly, we don't have any rocks on Earth, at least that formed on Earth, until about 4 billion years ago, because not only does our planet record its own history in rocks, but it erases that history with a number of processes too. And so the first 500 million years of Earth history is more or less the dark ages. As I talk about in my book, there are certainly minerals that come from those early time periods, and they tell us something about the early Earth. But it's really about 4 billion years ago that a rock record starts to be something we can look at. And so if you look at what's called the Archean Eon, from about 3.8 to or maybe about 4 billion years ago until 2.5 billion years ago, that's sort of the early history, the Stone Age, if you will, of the planet. And it's an Earth without measurable amounts of oxygen gas, so you and I wouldn't last very long on that planet. It's an Earth in which there was only limited exposure of continental masses above sea level. It was more or less a water world in those days. So it's a very different world. But the other thing we know about that world from the geologic record is life existed. And again, it wasn't mammals or dinosaurs. It was microbial. It was bacteria. And we know that photosynthesis existed way back then. So all the makings of ecosystems on Earth, where different organisms cycle carbon and sulfur and nitrogen, the other biologically important elements through the system, that system was put in place in this microbial world of the early Earth. And to be honest, to this day, the biological world would be just fine without plants and animals, but it can't exist without these bacteria. They're the basic building blocks of ecosystems on Earth, and they evolved very early on this alien planet. Now, we move to what's called the Proterozoic Eon about 2.5 billion years ago, and that will last until about 540 million years ago. It's a long period of Earth's middle age, and that begins and ends with very important changes. About 2.4 billion years ago, the geologic record tells us that oxygen gas is starting to accumulate in the atmosphere and surface oceans. Not a lot. It didn't make it a modern world in terms of atmospheric composition, but enough oxygen that organisms could start to use it for things like respiration, what you and I do when we eat something and then derive energy from it. Again, we know that the source of the oxygen was photosynthesis, so you need a biological component. But this happens at a time when continents are emerging and to form, large continental masses and mountains. And those are now increasing the amounts of nutrients coming into the system. So the way I see it is that it's a combination of biological processes and physical processes that together really transform the Earth into one that has oxygen. And that begins Earth's middle age. And it's sometimes been called the boring billion. But in fact, it is a time of prolonged warm climates, not much oxygen, certainly no oxygen in the deep ocean. The deep ocean was actually rich in iron in those days. But again, at this point, by about 1,700 million years ago, we have evidence that not only are there bacteria, but there's a new type of cell called the eukaryotic cell, cells that have a membrane-bounded nucleus and other features, the cells that make up our own bodies, for example. So the world is changing. And then toward the end of this eon, it changes again. We start having more oxygen. We have major ice ages. And amid all of this, for the first time, we see fossils of animals. So the Earth has now entered a new state called the Phanerozoic Eon, the age of visible animals. And that's when a more familiar Earth history begins, that there are fossils of various types. We have evidence of ice ages, of mass extinctions, eventually leading to our own lineage, and really only in the last, blink of an eyelash, as far as Earth history is concerned, to technological humans that themselves are capable of changing the planet. So to put it all in perspective, when you go to a museum, you'll often see fossils, and they're fossils of animals and maybe plants, but those only really record the last 15% of our planet's history. Most of Earth history is microbial, and most of it is in a world that's physically very different from today.